A single point of failure. If you lose your seed phrase, you lose everything. Traditional Web3 wallets have suffered with this problem since way too long. As you can see with these examples, where LastPass was hacked and many seed phrases were leaked and all of those assets were vulnerable. So how can we fix this? Welcome to ChronoVault, a smart wallet with two-factor authentication. So even if your seed phrase goes public, your funds will be safe. So the flow goes like this. You set up your TOTP on your authenticating device, which would be your smartphone typically. So that will store a secret phrase. We use Poseidon hash to calculate this, so it's ZK friendly for the smart contracts as well. You verify the TOTP and complete the setup. The secret does not get stored on the transaction device. It's only on your phone for now. Now you use that TOTP secret and a hash that was generated using that to deploy the wallet onto the blockchain. Now you fund the wallet with a little bit of Ethereum to test some transactions. After we do that, we'll confirm it, and now we test some transactions through the smart wallet. So let's just send some Ethereum back to ourselves. We'll just do that. We'll send a small part of it back to ourselves. So now these are your transaction parameters. We use these inside the zero knowledge proof itself. So this prevents replay attacks and front running as well. So we'll look into that later. So we scan these parameters onto the authenticating device, which then uses the secret that was stored on it to generate a zero knowledge proof that I know this secret and I am verifying this transaction. So then all of these proofs are then scanned on the transaction device. We split the QR codes, and as you can see, we expect to receive the same Ethereum back. And that should succeed. Yep, there we go. We have successfully received back our Ethereum. Now let's create a fake account with a fake secret to make sure that our product is working as expected. We'll test the same transaction, but this time we'll use this fake secret to generate a proof. So again, a similar QR code is generated. We scan that to get the parameters onto the authenticating device. We use the fake secret to generate the proof this time. And now we still have some sort of proof. Then we try to scan that to proceed with the transaction. There we go, 1, 2, 3. And now, as you can see, MetaMask itself is telling you that the transaction will most likely fail. But still, let's try to do that. And as you can see, the transaction just fails. So you cannot do that with the incorrect secret. In wallets, we cryptographically bind your authentication to the exact transaction you're approving. Not just are you the user, but did you approve this transaction? Even if someone steals your wallet key, they can't execute transactions without your authenticator device generating a zero knowledge proof. And because we use ZK snarks, your TOTP secret never touches the blockchain. 2-device protection, no multi-sig complexity, and it costs much less gas. That's secure, private, and fast. Because we use the transaction parameters in the ZK proof itself, we automatically fix a lot of the potential security threats. Front running becomes useless as transaction integrity needs to be maintained for the proof to be valid. The attacker can't replay the proofs due to nonce increment protection. Thank you from Team Object.